So William, I want to get into like what brought you here, specifically around your experience in the analytics space, maybe in prior organizations that you worked with and jobs that you held, technologies that you've used maybe, and then the approaches you took, and maybe what you learned in that process, and what made you realize there was a gap in the marketplace.
Yeah, well, I mean, a lot of that stuff came to me relatively late, I would say, or, some might say it's still coming to me or hasn't come to me yet. I don't know. In the early days, I kind of got started off, like I always thought of software as a way to solve problems. I viewed what I did as like solving problems, but in an automated way. And, I did some stuff with like early AI and, defense projects and whatever. And, I think that was kind of our whole mindset. And then it really wasn't till years later, looking back, that I realized like how important capturing the structure of the data really was. Although that was actually our focus at the time, the company I was at, that was sort of what we were good at. But like seeing how much value that had relative to other commercial solutions in the marketplace was something I came to later. And then, over the next few years of my career, a lot of what I did was focus on different aspects of user experience, where a lot of it was not sort of pretty pictures and colors, but really was the interactivity or the time latency that a user experienced. I had a lot of projects that revolved around that. And so, to me, I think these two things kind of converged into a world where then, and then I did the same thing over and over again for the rest of my career.
I'm going to stop for a second. I think you hit on something really important, which is in most organizations that I've worked with, they undervalue that query experience that you just alluded to, because as a consumer, I'm so used to sub-second query time on the whole internet, right? And then I go to an organization which in theory has a finite data set, and I'm having these long wait times or queries that I just can't make feasibly. And so I think you hit on something important, which is there's an expectation, I think, in the enterprise space around what I should be able to do and what I can't do. And I've talked to you before around, you wanted to almost reset that expectation a little bit and give people what they actually wanted.
I completely want to reset that expectation. And in particular, I want to push back on you that it's the internet that led to that change, though, I mean, and I can find plenty of websites on the internet that aren't fast enough.
Sure.
But no, human beings don't like waiting on software, and they shouldn't. Right. If it's under a quarter of a second, they don't notice. If it's under a second, that's good. If it's under 2 seconds, it's okay. And somewhere between 4 and 8 seconds, they're thinking about getting a cup of coffee already. So that's the amount of time you get. That's, I like to talk about human time queries or human time interactions. If it's slower than that, generate a report and email me later, and I'll come back. But, and that's really what you get. And this leads to a bunch of weird and sometimes non-intuitive ways to think about performance for engineering professionals, where, if you can make something 20 times faster, but it currently takes 0.8 of a second, don't bother. No one cares, And frankly, if it takes 80 seconds, maybe still don't bother. It still might not be fast enough for people, But if it's 8 seconds and you can make it 20 times faster, absolutely do it.
Yeah.
So there's just an elbow in the curve, and that's because a lot of software is engineered for humans to do work, and that happens to be our time span that works for us. So, there's a range where you should pay a lot more attention to this stuff. And if you're already in the slow space, fine. People get whatever. And if you're already in the fast space, fine. Unless you're doing, microsecond, trading on Wall Street, no one else cares. So performance. Performance really matters. And I think it's really data quality, which has many elements to it. Human scale performance, so that you can use it in the right ways for the right things. And then, time to market. And time to market also has many aspects. Not just, are you building a product or are you building a new project internally, but also, are you fixing it? Are you fixing a bug? Are you redoing it? Are you, loading new data? Are you like relabeling things? These are all time to market loops. And, again, there's sort of a natural time frame where a project that takes hours, you do before lunch. If it takes a week, well, I'll get to it sometime this month. If it takes a month, maybe you'll get to it this year. So the amount of calendar time that things take just expands almost exponentially with how long it takes in person time to get stuff done and get it scheduled. a lot of my early experiences dealt with these things in kind of a disconnected way. And, then I had the good or bad fortune to kind of spend my career mostly at data-oriented businesses, one after the other in different spaces, with this sort of background. And I saw these challenges over and over again, and I came to a couple of conclusions that eventually became sort of systematized in my own thinking, and now are systematized in our product as a result of that. And one of them is I kept coming back to search as a platform. So databases are either big or fast, but not both. If you want to take Postgres is a great database. Love it. It's super cool. If you get to about 200 million to a billion rows of data in a single table, you will start having problems. And yeah, sure, can you shard it? Can you whatever? But now you're picking sharding keys, and then you have query patterns that cross those shards. And so when you start looking at ad hoc exploratory queries, you need to always be thinking about your worst case query time. You can't optimize for best case cached performance, things like that. Caching actually is an anti-pattern in this world. I know I'm kind of all over the map here, but this one matters to me a lot.
It's a good, I like it.
So the problem with caching is it works if everyone asks the same query. When you're exploring a data set, trying to find things you don't already know, you never ask the same query twice. So any resources you spend on caching are just total waste. In fact, they're often harmful to performance.
Value, right?
You're adding cost,
or adding cost,
and you're often adding time because it checks the cache first. And so as you move from, and this is how the consumer grade web is mostly built. So we have this expectation, this desire, this need for things to be in a time frame that feels comfortable to us, definitely under 4 seconds, preferably under 2 seconds. And a lot of the consumer grade web gets there by caching, by having common patterns that are evaluated where 80% of the people ask the same question all the time. You can't do analytics that way. You got to do it some other way. So you move into the database world. If you put a billion rows in a single table of Postgres with no shards because you can't anticipate the query patterns, it's just not going to work. I mean, I know databases pretty well. My co-founder knows databases really well. We can't make it work. If you can, you will have lifetime employment. Good for you. But this is why people move to column store type data stores, whether it's Redshift or whether it's Snowflake. These are data stores that are built to be able to handle bigger data. They're reorganized. But now the query times are not ever going to be as good in general. So your worst case query performance for complex queries is often going to be 10 minutes, sometimes hours. You can usually design pathological queries that'll take days or just hit whatever resource cutoff your cluster is configured to. So, okay. Search has a great pair of properties. This is why Google uses it. This is why we use it for a certain set of problems. It's big and it's fast. What it doesn't have is it doesn't have the structure of a database. It doesn't have the stability of a database. It's not easy to manage. And the resource tuning of how you apply different CPU, RAM, disk resources to your problem is complex. So what you get is this much more complex piece of technology that has the virtue that it's big and it's fast. So I kept coming back to this over my career in different stops. Sometimes it was because I was managing long-lived person data sets, and in order to maintain their identities, we needed a canonical store that could be updated in place and queried in near real time over very long periods of time, which is pretty much impossible to do with a database or most other data resources. Sometimes it was just because I had more than a billion rows of data that I just wanted to throw in one place and be able to query it really fast. And sometimes it was because I didn't know what I was going to have, and I was building a best case platform for a worst case solution where I didn't even know what the problem was going to be. And in those cases, I ended up just kind of exploring some of the same concepts. So what we do is we build a data warehouse on top of a search platform, and it has some disanalogies with RDBMS-based data warehouses, but it is both big and it is fast. And as a result, it replaces both the data warehouse layer of a traditional architecture and the data mart layer. And you never do nightly batch jobs, you never count, you never persist your aggregates, you just do them at query time. And so some of the beauties of that, you get near real-time latency effectively for free because I don't have the batching, aggregation, counting, caching layer. If you clean up the data or deploy a new data set, you get a new answer instantly. And you never run into so once upon a time, in an earlier version of this talk, used the word reporting. And I said, I don't like that word.
Yep.
Reporting has a semantic sense to it that you have figured out which reports you want to look at.
Yeah.
And what ends up happening is you say, oh, I'd like a new report. And invariably someone says, oh, well, we'll have to like define that and deploy it. We'll get you the results tomorrow. Or they say, oh, the data's not organized that way. We're going to have to like re-persist it or add a new, batching aggregation layer to our system. It's going to take a week. Or they say, we don't have that data at all. We never thought anyone was going to look at it. We're going to have to go back to the raw data, update our ETL processes, replay all the data we've ever collected in the history of our company, then build you a new aggregation layer and a new report. It's going to take 3 months. So when you're in the world of reports, you live with things like this happening. And because you'll live with things like this happening, you don't ask for new reports very much unless you really, really, really want them. But what happens is you throw out all the questions of, I wonder if this is true. Like that would be too expensive to do just to like, I wonder if this might be true, Once upon a time, I looked at a telecom data set and I found something that I guess people in the industry know, but it was new to me. Hispanic families use family plans and African-American families don't. And so, from a marketing point of view, that's an interesting thing to know. But the reason I found that out as just a data guy poking around in this data set is I just asked 1,000 questions and the other 999 weren't interesting, So that's, at the end of the day, that's what an analytics platform is for the 999 questions you don't remember asking, because that's the price you pay for the new stuff. And you can't do that with reports. You can't ask for 1,000 new reports that are going to take 3 months and then just look at the one that generates gold. You just won't do it.
Right.
It's too expensive.
That's right. That's right.
Yeah, I mean, it really was those kinds of experiences. And, I've done it on Wall Street. I've done it in life sciences. I've done it in entertainment, most recently in marketing. And ultimately, from my point of view, I almost built the same thing every time, just better.
But you had to rebuild it effectively from scratch, right? Each time. And you're looking at the marketplace and saying, why does everybody have to rebuild this from scratch? Why can't you use a product and hence you're here?
That's right. And so when I left Warner Media and I started this company, I said, I want something that's like the last version, so just like each version was a better thing. And I had, I have a new, better thing, but I'm tired of building it by hand. I'm here and I'm building it by hand. I'm here and I'm building it by hand. I'm here and they're better. It's time to stop building it by hand. And so this time I built software that builds the software. So, I think in the early days of me starting this company, someone asked what it was we do, and I was in a particularly sarcastic state of mind. And I said, well, we build software that builds software that builds software that mostly our customers use to build software for their customers. That's the business we're in. And it's true. It's literally true. We don't build the analytics platforms. We have software that builds them, which is why I don't talk about data lakes. I talk about data lake building as a feature. But actually, we don't build that software either. We built a common piece of software that builds both, and we use it to build the software that builds your data lake for you. So, at the end of the day, it's all a little like tight, self-referential bit of code. And, it's a search platform. You can kind of think of it as a peer of like an Elasticsearch or a Solr or something. In my last few gigs, I was using Elasticsearch and Solr, and I know what does not work well for them. So we basically just ripped out all the parts of that we don't like, replaced it with things that work better, had to pretty much re-architect the whole thing. But then under the covers, it's still like a Lucene-based search index and stuff. We didn't, have to reinvent that stuff.
Hence, you can rebuild it, like you were saying, because with search, typically, if you don't like your index, you throw it out and rebuild it because you might have, a better optimization. You're kind of taking a similar approach where your engine or your resulting, do you even call it a database?
I usually call it a data store.
A data store, okay.
Which is a generic term.
I was going to say it's
really
generic on purpose, right? Because again, you're considering that almost CPU time more than anything else, right? Because you're generating a data store to report, to do analytics off of.
I mean,
right?
it turns out like making sure that you've got the CPU to RAM to IOPS ratios right is really, really important at this layer. And so we've put a lot of work into that. But at the end of the day, you just want to be able to query, and the thing that's happening in the middle, the end user who's querying it doesn't really care what that is. That's
right? Now, what if I say, hold on, I need to regenerate this thing, or I haven't generated it yet?
Yeah.
if you have a huge database that I'm, or several data sources, obviously, that are coming into what I'm going to do my analytics off of, when you say rebuild, is that like a overnight thing, or typically how, I guess it really depends on how big those data sources are, right?
So like with everything we do, we tend to optimize for worst case performance rather than best case performance. It's great if something that takes other people 5 minutes takes you 10 seconds, but if I never ever take longer than a couple hours and you sometimes take 50 days, that's a better thing in my world, or at least that's the way I think of things. So one of the beauties of search is that the CPUs available scale with the data set size. And so we always have linearly the same amount of CPU available. So all of our writes are constant time, all of our reads are constant time, and the cost is linear because if you have 10 times as much data, you pay for 10 times as many CPUs. That's a great performance ratio.
So you can scale up and down equally well, effectively.
So the answer, down to our point. Step size.
Of
like
course.
we have our minimum. This is the smallest box I can sell. Which, if someone would sell me online a smaller box, I'd sell it to you too. But there's sort of an atom at the bottom.
Sure.
And but the answer to your question is we can build a terabyte data lake in in a little under 3 hours, and we can build a petabyte size data lake in a little under 3 hours. And
that's amazing.
Yeah. So. Among the dumb, sometimes the fun lessons you learn are the dumb lessons you learn. And there was one day, it used to take about 10 hours. And I thought that was pretty good. You set it today, it'll be ready when you come in the morning. That's, have a whole new data lake when I come in tomorrow morning. I was pretty happy with that. And one day a lightning bolt hit me and I'm like, oh, I could just apply a lot more CPU to this problem, and we got it under 3 hours. And so the same way I have a smallest unit size just because it's what's available to me, the reason I can't go faster is because no one will sell me more ratio of CPU to disk than that. But if someone would sell me twice as much CPU to disk, I'd just use twice as much and it would get done in half the time. But the boxes start getting to be weirdly shaped and no one wants to sell them in the cloud. So I want a box with 96,000 CPUs and 500 gigabytes of disk. It's just like a weird profile. But this is what we try to do is depending on what task you're doing, this task needs CPU for this much disk. So let's deploy that. And we have automated software that does that. And then this task, you need this much CPU for this much disk, but you need really high IOPS. So let's deploy that.
Does this all relate to the fungibility aspect? Or
no,
not?
This is actually different, interestingly enough.
Because the funny thing is, this elasticity is what comes to mind. But it's elasticity of the computing resources in the cloud. And I feel like the cloud is helping you solve this problem because of the elasticity.
So,
but I don't know if this is a good segue, maybe, actually.
We should. Why don't we pause and start with that as a new question? It's actually there's a good little riff there.